So before I begin, I want to talk about spam phone calls, which I get a lot of. You know the sort. It's kind of like, have you been in an accident in the last 200 years? Would you like car insurance for all of your pets? That kind of thing. I actually get enough of these calls that I've started inventing games to play. And my favorite game is And in this game, I become the most indecisive person that has ever existed. It goes like this. Hello, Mr. Archibald. Are you interested in saving money on your mobile phone bill? And I reply, I suppose if, And at this point, the caller usually tries to hurry things along, but it's very important that you do not let them. They say something like, well, we've got this great deal, and you're, wait. Do you, is it one of the, And you get a point for every second that they aren't talking. And it's a really difficult game because the caller gets frustrated pretty quickly because you're directly blocking in a conversation, which is a very synchronous transaction where each person wants an instant response, and you're breaking that model. We expect a similar model when it comes to getting data from a computer, but that wasn't always the case. 25 years ago, our expectations were pretty low. If you wanted to know directions somewhere, you would first have to go to the room with the computer in and turn it on. And all the fans would start whirring. You get that lovely static crackle as the CRT monitor whirred into action. Slowly but surely, Windows 3.1 would boot up. Eventually, you would get your desktop, and then it did this. This was an era where booting up successfully was a fanfare-worthy moment. But after that, you had to find and insert the CD that had all of the maps on it and print out the directions, and off you went. These days, we don't need to boot up Windows 3.1 because we have a computer in our pocket that is already booted up. We can ask it for directions. But often that data comes through the internet. And if you have zero connectivity and you ask for something, the web's answer is often no. And I remember when I realized how problematic this is. A few years ago, I was working at an agency, and I found myself needing to go to the toilet following a lunch that my stomach was rather unhappy about. Now, there were 5 cubicles to choose from. But in this instance, the first 4 were occupied. This is usually okay. I mean, even in this situation, I felt that 1 cubicle would be enough for me. But from previous experience, I knew that mobile connectivity and office Wi-Fi only extended to the first 4 cubicles. And I thought for a moment, and I decided, no, this isn't acceptable. And I returned to my desk and I waited until later, despite being in a certain amount of discomfort. And this is the day that I discovered that I required an internet connection in order to take a dump. So this is a problem worth solving, right? And until recently, there was nothing you could do about it, especially during the initial page load. But that all changes with the Serviceworker. I was told this slide isn't impactful enough by my boss. I don't know, it's one of those management words I don't really understand. But I gave it another go, came up with this. He says this has brand issues, which it's got loads of brands in it. It should be fine. Bruce Lawson, the CTO, the deputy CTO of Opera, he gave it a go, and he came up with this, which I quite like. It's slightly weird, because if you stare at it long enough, it looks like the colors are changing. The colors are changing. I put a filter on it. But Ben Jaff at Udacity, he no longer works at Udacity, but he did at the time, he had a go at it, and he came up with this.
For too long, users have been left staring at a white screen. For too long, they've been let down by the cruel seas of network connectivity. And for too long, we've been powerless to help. We've been left waiting. But no longer. A new browser feature has arrived. A total game changer. A feature that lets you control the network rather than letting the network control you. Who is this new feature? And what promises does it bring? Introducing the Serviceworker.
It's a bit much, isn't it, really? I much prefer mine. It's got Sonic in it. But what can the service worker do? What does this all mean? Well, we're going to take a look at Emoji. This is a little progressive web app that you can find at this URL. It's like a simple version of Google Hangouts, but it only lets you enter emoji. It started life as a mere website, meaning it's completely terrible offline. But here's how I fixed it. To begin with, from the page registered for a service worker, it's not some magic manifest or a config file, it's just JavaScript, because why invent some new thing when we've a world full of JavaScript developers out there and loads of existing tooling? Oh, of course, we should wrap our register call in one of this, like this basic feature detect, because there are older web browsers out there that don't support Service Worker, and a simple feature detect prevents them from hurting themselves and others around them. But in that script, I'm just going to add a listener for this fetch events, because the Service Worker is very driven by events. And when I do that, I can refresh the page, and I hit that breakpoint, that debugger statement. But in this event object, it's got this request property, which is representing the request for the page itself. And you can find the URL, the headers, and all sorts. But I also get one of these events for every request the page itself makes, like the CSS, the JavaScript, the avatars, even though they're actually to another origin. By default, requests go from the page to the network, and there's not a lot you can do about it. But once you introduce a service worker, it intercepts requests. It controls pages, and requests will go through it. But like other events, you can prevent the default and do your own thing, and that's where things get interesting. A good way to dip your foot into the service worker pool is to make an offline fallback page, something to show the user if the network fails, if they're offline. Now, because the current state of things is pretty bad, the user comes to us wanting our content. It's our moment to shine. But without a connection, we crap ourselves to the extent that the browser has to step in and defend us, and it does this by blaming the user. Chrome can't display this page because your computer isn't connected to the internet. If we're going to compete with native apps, this is like an operating system error message. We can do better than this. So I created a custom error page. It's still an error, but at least we're owning the error, and we've got our own brand around it. So we want to show this when there's no connection, so it needs to be available offline. So we need to store it up front somehow. The service worker has an event for doing all of this upfront work, and it's the install event. And I pass a promise to event.waitUntil to let the browser know how long the install process is taking and whether it succeeds or fails. The install event is fired the very first time the browser runs the service worker. It's your opportunity to get everything from the network before you start controlling pages. But for storing these requests and responses, there's a new storage API. That's the cache API. It specializes in request and response storage, but unlike the regular browser cache, the browser doesn't just remove single things at its whim. Things are there until you remove them. So we put all of our stuff in this cache. And once that's done, the service worker can move in and start controlling pages. So let's do that. Let's do that with code. So I'm going to open a cache. I'm going to call it static v1. You can call it whatever you want. This is what I'm calling it. And then I'm going to add the offline page and the CSS it requires. But now we need to use this cache, and we do that in the fetch event. So here I'm going to set up a fetch event. I'm going to respond with, this is me saying I actually want to handle this request myself. I'm going to respond with a match in the cache, one that matches this request. And that returns a promise for a response if it can find a match. If no match is found, it resolves with undefined. So if it's a falsy value, like undefined comes back, we can defer to a fetch to the network. So we're going to the cache first and then falling back to the network. If the fetch fails, it will reject this promise, which will be the case if you're offline and there's no match in the cache. So I'm going to catch that, and if it's a navigate, then I'm going to serve the offline page from the cache. We only want to do this for navigations because if an image fails to load, it doesn't make sense to serve up this HTML file instead. But that's it, a fairly small amount of code. So how has this changed things? Well, to find out, we're going to pit the original online-only version of the site against our shiny new service worker version. Let's go to the comparinator.
Fight!
First up, online. So I've added the site to the home screen, which is giving it this icon here, and I've completely closed the browser, and I'm going to launch them at the same time, and that will include actually loading the browser as well. So, go! Okay, so it's loading in a reasonable amount of time. There's no difference between the two. I recorded these with a throttled internet connection, or as most of the world calls it, their internet connection. But you get this nice splash screen you saw there as part of having using the web manifest in the head of the page. Anyway, how about the offline experience? Go. So now we're taking responsibility for network failures. We're catching the error. This is something we can ship. And The Guardian did this. On their developer blog, if you don't have any connectivity, it serves you this kind of custom error sorry page. But there's a nice little Easter egg. You can also do a crossword while you're waiting for your connectivity to return. This is a really nice little feature, nice little Easter egg. When developing offline-capable sites, it's a common error to start iterating on this, like make it show cached messages, the last messages we received, to make it a fuller offline experience. But doing that is an online-first approach, which works fine if the user is truly offline. But zero connectivity is not the worst thing we face. This is. I call it Li-Fi. This is when your phone says it has connectivity, but it doesn't. You can't get any data down it. And if you have Li-Fi and you ask for content, the web says, and it's just that forever. This is worse than offline. With offline, the user gets an answer quickly. It's no, but at least they get a quick answer. But here, they're just left waiting. And with every passing second, they hate the user experience a little bit more. Our current online first pattern works great when the user has a good connection. They get the latest messages pretty fast. It's great when the user's offline because they instantly get some cache data or a custom failure page. But with Li-Fi, that's it. Like Chrome removes the splash screen when the page renders, and with Li-Fi, the page never renders. So we've improved things for offline users, but Li-Fi users are in the same hell as they were before. This is the problem with online first. We're giving users with some connectivity a worse experience than users with no connectivity. And this is just down to problems on the user's device, like connectivity. I don't know if you've experienced this before. I get this a lot, where my phone says it has full signal, but I can't get any data down it at all. So a lot happens to get data from the web. Like the phone needs to send a request to the Wi-Fi router or the cell tower, then onto the ISP through intermediate proxies, potentially across to the other side of the world, and then through more proxies. And eventually we'll reach the destination server. But that's only half the journey, because the response comes back. It goes through all the same proxies, across the world, et cetera, through ISPs, over the air, and hopefully land on your device. But if something along the way runs slowly, the whole thing runs slow. And therein lies Li-Fi. And you don't know how good the network is until you try, and that takes time. There are a couple of web APIs that attempt to predict the network, things like navigator.online and navigator.connection.type. But these are really weak signals. They only know about that bit. They don't know anything after that. They can't predict that. So, for instance, when navigator.online is false, you have no connection. That is absolutely certain. When navigator.online is true, you have no connection. This will be true if you're connected to a cell tower or a router. Although that router may only be plugged into some soil, navigator.online will still be true. You have to make a connection and find out if you have this connection. It can't be predicted. And doing that network connection to see how things are, that takes time. So if the user wanted to come to our chat app and look at past messages, why should they have to wait for a connection for that? Why should the user have to wait for a connection to fail to see things that are already on their device? The great thing about local data is they don't need to make an internet connection for it. So this is why the gold standard is offline first. Offline first solves these problems. With offline first, we get stuff from the cache, like local stuff on the device, and then try and get content from the network. And the more you can render without going to the network, the better. You kind of treat the network as a piece of progressive enhancement, an enhancement that might not be there, like in the offline case, or might be just permanently hanging, like in the Li-Fi case. So we need to rethink our approach a little bit here. We're going to create an application shell. An application shell is just like the shell of the site, without the content. And we'll leave it to JavaScript to add in the messages from the network, or display a failure message. So to do this, we're going to change our install event. So we're going to cache this page shell and the CSS and the JavaScript it requires. And meanwhile, over in our fetch event, we're going to get the URL so we can parse it and pull out the various parts. And then if the request is to the same origin as the service worker and the path name is just / like it's the root of the site, we're going to respond with the app shell from the cache. Done. If it's not this URL, we're going to respond with the cache falling back to the network. So by doing this, what do we win? To find out, we shall return to the comparinator.
Fight!
I enjoyed that jingle the first time, but it feels like diminishing returns now. Anyway, how are we doing? The online experience. Go. We can see we've really improved performance by just switching around the model like this. This is the power of offline first, because we're improving things across all the different connection types. Even though the networks were still coming over the messages here were still coming over the same network as they were originally, because we get to render quicker, because we get to load the JavaScript quicker, that request for new messages is going out way sooner, so the result is much faster. What about the offline experience? Great, the app shell loads and the page's JavaScript shows this connection error, so that's as good as it was before. But what about the Li-Fi experience? Well, we've defeated the blank screen at least. And we could do better here. We could have the JavaScript show a spinner or something, but things are looking better already. We can see the benefits of offline first here, this progressive enhancement approach to the network. So rather than improving things for one connection type offline, we've improved it across the board. We're back in control of the user experience. And it took very little code to get there as well, and this is something we can ship. This is another step in the process. But what about caching the chat messages so we can display those before connectivity as well? So apart from the initial page load, the messages come in one by one over a WebSocket. And this continual feed doesn't really map well to the cache API, which is request and response based. Instead, we want a store that we can add and remove messages from gradually one by one and sort of iterate over them and index them. The web platform has such an API. It is called IndexedDB. IndexedDB has a bit of a bad reputation among developers, but that's only because it's the worst API ever designed in the history of computer science. Other than that, it's actually pretty good. But seriously, 60% of the awful here comes from this weird event system IDB uses, because it predates promises. If it was designed today, it would use promises. There is an effort underway to try and see if there's a backwards compatible way we can fix this API. But in the meantime, I encourage you not to give up on IDB, but use a little wrapper on top, such as IDB, which is on NPM, which mirrors IndexedDB, but it uses promises where IDB should have used promises. It's a very small library. It's only like 1.2K. There are bigger APIs out there as well, things like Dexy, CouchDB, all of these things that sit on top of IndexedDB to make it easier to use. But this means we can store messages on the device as they arrive. Having a database full of messages means that we can fetch our app shell, the JavaScript, the CSS from the cache, but then we can render with messages from the database without going to the network. And then we can go to the network for newer messages. And once those arrive, we can update the page with the newer content. If the network request fails, that doesn't matter because we're still displaying content. That's a great offline experience. If the network is slow, that might be okay if the user just came to check an older message they saw. So to see the benefits of this, for one last time I promise, we must gaze upon the comparinator.
Fight!
Right, first up, the online experience. It's so quick and full content. The offline experience, same again, quick, full content. The Li-Fi experience, quick, full content. In fact, the experience is the same now with every connection type. The network only matters when it comes to fetching new content. This is something we can ship. If you do this sort of stuff, I think it's totally cool right now to brag about it a bit. This is something that the I/O website did. We can see that there, future visits will work offline, yay. And, I think that's fine. But I do hope this will eventually go out of fashion. I remember those little site badges we used to use that said, this site was built using CSS. And occasionally you'll happen upon one of them today, and you'll be like, oh, CSS, well done, you. And I hope one day this will seem as ridiculous. But before that, we do need to build up user trust here. Who's seen something like this before? This is what I'm greeted with in the bathroom on the train I commute to work in from Hayward Heath to London. First, if you want to use this, you press D to close the door, and then you have to press L when it's flashing to lock the door. Notice there's also Braille up here as well, which is great, so even blind people know they have to wait for the flashing light on the L button. And these buttons aren't even proper buttons, these horrible little touchpad things are on the day. I don't trust this. I don't trust this because once it failed on me and slowly revealed me to the rest of the carriage like a bad game show prize. Similarly, users don't trust the web to work offline, because it's failed them before. So messages like this do help. And yes, all epiphanies I have about user experience happen in bathrooms. But this is why Chrome requires there to be a service worker before it sort of starts advertising. The user can add this to their home screen. And in future, we're going to start tightening those rules to look for a really good offline experience. So we're really wanting the web to be competitive with native. So on that note, I wanted to compare Emoji, this web app, with a real native app, and in this case, Google Photos, a well-built native app. I wanted to launch them at the same time. And this is what happened. The performance is really close. Emoji was 0.2 seconds, 200 milliseconds slower to render content there compared to a well-built native app. But that's starting from cold. The browser isn't in memory. If the user has used the browser sometime recently, and let's face it, the browser's a pretty popular app on people's phones, so that's likely, this happens. What we're seeing here is a progressive web app beating a native app to content render by almost half a second. This is the power of things like Serviceworker and offline first. And achieving this wasn't a matter of rebuilding the entire app, it was an incremental thing, improving the experience every step of the way. It stops people being frustrated by the network connection they have. And this stuff is possible today. One app across thousands of devices, operating systems, and browsers. It works in Chrome and Firefox and Opera today. It's something the IE team, the Edge team, are working on right now. It's a high priority thing for them. Apple are being a little bit cagey about whether they're going to do this stuff, but progressive enhancement means you can do it today. And if you use Serviceworker and make your sites work quicker with this stuff, it's going to be quicker in Chrome and Firefox and soon Edge than it is in Safari. And that puts Apple in a position where they have to implement this stuff or fall behind, and that's not something they're in the business of doing. So as web developers, you really have the power here to guide the future of the web platform. Serviceworker lets us build great user experiences, like becoming faster, network resilient. I've gone through a lot of stuff really fast here, but if you want to learn more, there's a Udacity course. Just Google for Udacity offline first, the link comes up. And with that, I'm slightly over, so thank you very much. Cheers.
Jake Archibald, everybody. Thanks very much. So in just a second, I'm going to ask any members of the audience if they've got any experience with service workers or this offline first approach. Any questions for Jake? But first of all, I want to just ask Jake, so are we in an offline first world all the time now? Should everybody be thinking about this?
I think so, yeah. I mean, it's, there are people in sort of what we call the next billion users in India and such, where connectivity is bad all the time unless they're on Wi-Fi. But I mean, I think everyone in the room could associate with like the Li-Fi experience. There's some time when they're like, but I've seen this data before. I just want to know what pub Derek said we should meet at, and like I've seen this on this phone. Why can't it show me it? Why do I have to have a connection for that? Yeah. So it's a frustrating experience that's not going to go away. And like one of my colleagues who does a lot of performance work, Ilya Grigoric, says, is that the fastest request you make is the one that doesn't go to the network. It's the one you don't have to make. You just get it straight from the device.
Okay, cool. Are there any gotchas? Are there any ways that any reasons to avoid looking at this?
Not to avoid it, but it's. So there's a whole thing that's driving us right now called the Extensible Web, where we as standards developers and browser developers have finally kind of admitted that we are not better web developers than web developers. So rather than come up with these little package solutions for doing one thing, one particular way, which is what app cache was, and you'll see it like you'll get like a special prefix bit of CSS to do a reflection in one particular way. We decide we shouldn't be doing that. We should be giving the lower level tools. So we just kind of explain how the browser works, and here's where you can hook into various bits, and you work out the patterns. And then as browser developers, we can see the patterns that are common and go, well, this pattern's very common, but we can make this faster by moving it to C++ rather than doing it in JavaScript. So we can add another API. So the platform gets guided by web developers rather than sort of C++ engineers.
Yeah. So you're kind of making a call to arms here to the community to embrace this and take it forwards.
Absolutely, yeah. And then not just with things like Serviceworker, with all of the other sort of low-level tools that are coming out. And if you find some particular pattern that you like being slow, then make sure browser engineers hear about it. Talk to me. We're all on Twitter, and say that this is slow. It shouldn't be. It's a common pattern. What can we do to fix this?
Great stuff. Thank you. Coming to the panel then. Anybody got experience with offline first service workers? Anybody got any issues this might solve for them?
I've played around with service workers, and it's pretty great. But I haven't really tackled the Li-Fi situation. I've only done the offline because it's such a no-brainer. It's like, okay, well, I'll put my static assets, my CSS and JavaScript in the cache and go to the cache first for those. I was like, why wouldn't I do that? And then a custom offline page, again, it's like, well, why wouldn't I do that? It seems just so easy. With the offline first, which you start to get a bit more complicated, I'm going to dive into that, but I've basically just done the lowest level of Serviceworker.
Okay, but you can see a need for it in your work.
Oh, it doesn't matter what you're building. So there's a lot of emphasis on apps in a lot of the demos of this stuff, but on my own personal site, which is basically a blog, again, why wouldn't I want that to be fast? Why wouldn't I want people to be accessing, the blog post even if they're offline? So it really doesn't matter what kind of website it is. Pretty much anything can benefit from this.
Yeah, and the Li-Fi thing is certainly relatable. I think everybody can get why that would be a good thing to solve. Guys, at this end, any experience with service workers or offline first?
Yeah, I've not implemented any service worker yet myself, but I keep seeing really obvious candidates for it. And my favorite obvious candidate is conference websites. So you're at a conference, there's no Wi-Fi perhaps, or it's in a different country where you don't have a data plan, and you might load the schedule on your phone, right, at the hotel, on the hotel Wi-Fi, and you pop your phone open again at the conference and it tries to refresh the page and there's no network connectivity and you've lost the schedule. I've been at conferences pretty much non-stop this last month, and I wish every single conference site had a service worker for an offline page for their schedule. So there's really obvious candidates, like Jeremy says, it doesn't have to be apps, just anything where content is useful at any given time. I think it's a complete no-brainer.
That's actually the origin of Serviceworker as well. Because I was working at Lanyard a few years ago, and we wanted to make all the scheduled data for conferences work offline.
Oh, cool.
But back then, the only way I could do it was app cache, and it was, I think I was one of the first people to try and use it in anger, and then left me basically reading the spec and going, this is not suited for purpose. No one asked a developer how would I actually use this to build an offline experience. And that's when Google went, do you want to stop just snarking about it and come and fix it? And oh, I think I'm better at snarking, actually, but I'll give it a go.
Made a bit of a rod for your own back there.
Yeah.
Cool, thank you. Certainly a great use case. Anything in the audience there? Any questions for Jake? Yes, please, yeah.
We built a few offline first applications with app cache rather than with service workers. One of the issues that we've had with that is with user session state and content that comes in that's dependent, subject to the user's session state and is tailored to that user. Is there a framework for being session aware and ensuring that you're sandboxing user state data into?
Yeah, I mean, so you're in control of sort of every request. It's not just so app cache gives you a very one-to-one mapping of you can cache the thing that would be accessible at that URL. So there's a couple of ways you could tackle the particular problem. Is you could serve something generic straight away and then have the next wave of content filling sort of take into consideration the user session data. There isn't currently access to cookies from within a service worker. And that's just an API design issue because currently on the page it's a synchronous lookup, which it should never have been, really. It's causes loads of performance problems. So we just need to add an asynchronous API for that, which is being designed right now. But you can have the session data stored somewhere else, like IndexedDB, and you can use that in the service worker to kind of decide what to serve, or if you need to clear out caches because the user's logged out. Yeah, you should just be able to write JavaScript for this stuff.
Great, thank you very much. I'm looking for just one more question from the audience, please. Yes, please.
So why doesn't the browser cache deal with a lot of this stuff? So the browser's got an inbuilt cache, we've got cache control headers. Why isn't it dealing with, so we've got a basic HTML page, like a blog page. We put cache timeouts on all the assets. Why is it not already using that for us?
So I mean, it kind of goes back to the question from the other gentleman before, because if we just decided to sort of cache pages forever, it doesn't normally work.
I understand service workers give us more than that, but why isn't that already working for us? Why are we getting? So say I'm sending a static page and I put a 1-year cache timeout on it, cache header. The browser's offline. Why is it not saying, well, I've been told to cache this, here it is?
That should work if it's fresh, according to the cache control headers. One of the problems we have right now is if the way the spec's set up is if you hit refresh, it will always revalidate with the server. And the reason for this is just kind of a history of badly written caching headers. So we users end up with a situation where they'd click on something, they'd end up with a broken experience, usually because they ended up with like the CSS came from the cache, but the JavaScript came from the network, and you ended up with a version mismatch. And the JavaScript started doing something with didn't expect the older CSS to be there, and everything breaks. So having the refresh button just go to this, always revalidate with the server. You can still serve a 304 and go to the cache, but that's a kind of historical thing. So the cache will work for things like avatars, like we saw before, just plain cache headers. But you're sharing that cache with like the rest of the web that the user looks at, and the browser is free to delete resources from the cache on a file-by-file basis. So you kind of really can't do anything with the main browser cache that has interdependency, whereas the origin storage that the Serviceworker in IDB has part of, the browser cannot remove individual parts of that. It has to be all or nothing. And the browser will only do that now if the device becomes under storage pressure. And there's a spec which is just starting to land in Chrome, which was designed by Mozilla, but this where you can request persistent storage from the user. So once you've gained permission from the user to store stuff on their device permanently, it's now the user's responsibility to remove it. So if you wanted to store gigabytes of movies, you could do that, and the browser would never remove that unless the user asks them to. So if they do become under storage pressure, they'll be presented with a list of things that are taking up space, and they can decide, well, I'll delete that game, but not these movies for the flight I'm just about to get on.
Great, thank you. Great question and very in-depth answer. Thank you very much. Jake will be hanging around between sessions, so do feel free to pick this up again offline. At this point, I'm going to ask Lucy Bikes to just wander over and check her slides are in order. Thank you very much. I should just mention, actually, a shout out to the sponsor of this episode. If you ask around in York, Bytemark Hosting have been developing a very solid reputation for reliable hosting and great customer support. Very grateful to them for sponsoring this particular episode. Of course, they've also got servers in York, so if you feel the need to visit them and stroke them and that sort of thing, that's also an added benefit. So thank you to Bytemark.